I digress. The quizzes just aren't going to get fully recorded. I've just come to the fact. Now, yes. But it also records for period 3. For the ones if they're missing. If everyone's here, it doesn't matter. Now, 3 says, when the rational expression 2x plus 4 over x squared minus 4 is simplified, the equivalent expression is. So we have to simplify this, correct? So what do we do when we simplify? GCF difference of square is the numerator. GCF difference of square is the denominator. So the top, I can take a 2 out. And I have an equal sign. X plus 2. The bottom, I can take out nothing. But it is a difference of squares. Square root of x squared is x. Square root of 4 is 2. And then plus minus. All right. I see something I can cancel. I get very excited. I'm not so stupid. I'm like, yes, I got something here. But, yes, you have to do the non-permissible values, or the restrictions. So our non-permissible values or restrictions are x plus 2 can't equal 0, x can't equal negative 2, x minus 2 can't equal 0, x can't equal 2. So x can't equal plus or minus 2. And then these cancel, and I'm left with 2 over x minus 2. X can't equal plus or minus 2. Which is? Which one? Okay, B. With appropriate restrictions, the simplified form of this is. So what can I take out of the top? A 2 and a b. I'm left with b squared minus 9. And the 2 and the b can go in their own brackets because they're not stuck together. Yeah? Yeah. Did I say b squared? Well, I said b. I squared, but I wrote the right one. What? Oh, this is just b.
You're very wrong.
Disappointed. I wanted to do difference of squares.
That's what you do on the bot. No, that's a lie.
That's a lie, too.
You expand them.
Yes. Well, you don't expand it. So, well, you kind of, but not. So, b, what does the b minus 9 squared mean? You write it twice. You don't go foiling. Because if you foil, you're just making it messy, right? You're expanding, not simplifying. So my NPVs are going to be b can't equal 0. And b minus 9 can't equal 0, so b can't equal 9. And then cancel, cancel, 2 over b minus 9. Okay? Remember that? Now we're going to flip to the notes and we're going to do division today. The only thing that division causes you to do is flip and multiply. So you're going to do all the same steps as multiplication yesterday, but you get an extra non-permissible value spot. So we're going to go to this one first. It's at the top before dividing rational expressions, at the very top of the page. Everyone should have their notes open, looking at their notes. Open your books up if they're not open. Math, that's you. Notes. So, with the appropriate restrictions, the product, what's the word product mean? Yeah, it's the answer to a multiplication statement. So they could say product of this and this, and then you have to know to multiply them. The product of these reduces to a whole number. What's a whole number? No decimal and no negatives. So the whole number starts with a number with a whole, which is 0, and then 1, 2, 3, 4, 5. No decimals. Always remember to fill numeric response from left to right, and you do not have to fill in all the boxes. Some people will go like 2 decimal 0, 0. Please don't do that. The little bubble sheet computery thingy will say you're wrong. Okay? So try this one out. You're multiplying the 2. You should get a whole number. Top left, what can I take out? 12. And I'm left with x minus 2. Bottom I can take out a 3. And I'm left with x squared minus 4, which we'll get to in a second. And then I was just like doing the dot 6. I'm left with x plus 2. and then a 2. The x squared minus 4 is just difference of squares. So we're going to get 3x plus 2, x minus 2. 6x plus 2 over 2. Then we have to state non-permissible values for just the denominator because this is multiplication, right? Does the 3 get me an NPV? No. Does the x plus 2 and the x minus 2? Yes. X can't equal plus or minus 2. And then the 2 doesn't. Because it's multiplication, I can just draw a straight line. What cancels off? Yeah, we'll deal with that in a second. So we're going to cut these off, cut these off. Now, we can reduce those. We can take 3 out of these and 4 and 1. We can take a 2 out of these and it's 3 and 1. Or you can just put them together and go 72 over
What goes into 72?
6. No, you don't.
6 goes into 72 12 times.
Yeah. Or what can you do? 72 divided by 6.
Oh.
Every single time. Right? So sometimes it's actually easier just to put them together because sometimes when people are reducing them, you get mixed up with what is where and what's left over and what you can multiply and all that stuff. So it's 12. 1, 2. Don't need to fill in all the boxes. Right? Now, these are the steps for dividing rationals. Really all you need to know is flip it, multiply, right? That's it. That's the only extra step. What you do need to remember, though, when you flip it and multiply, though, is that you have to state non-permissible values for the denominators that existed, right? And the c, because it will be the new denominator. So, with division, the only one that you actually have to state non-permissible values for a numerator, right? Because it's going to become a denominator. We agree? All right. Example 1. X minus 3 divided by 2x minus 5, over 2x minus 5 divided by x plus 1 over x. So the very first thing I always do is flip it and make it a multiplication. The problem with that being my move is, if I flip it and make it a multiplication, I have to remember to state all my non-permissible values. Okay? So, we have equals on the top, x minus 3. Can I do anything to it? Nope, x minus 3. In the bottom, 2x minus 5 times, and then I need to flip them, x over x plus 1. The problem, like I said, is you have to remember this, and this have to be stated for non-permissible values, right? Because the x was in the denominator, and now the x plus 1 is in the denominator. Does that make sense? So often on any unit test or on any diploma, they're going to ask a division question for the non-permissible values, because it's the only one that's a little bit tricky, right? Because it involves the other numerator. So we can't reduce any of these because first question I made it easy. So let's find our non-permissible values. So we have 2x minus 5 can't equal 0. We have x can't equal 0. And we have x plus 1 can't equal 0. The x can't equal 0 is done. And then this one's going to be 2x can't equal 5. And then divide by 2. X can't equal 5 halves. And then this one will subtract 1. X can't equal negative 1. I like stating them together, so I have them all together. So x can't equal negative 1, 5 halves, and 0. After this lesson, we only have 2 lessons left in the chapter. Adding, subtracting, and solving. Yep. Unit tests happen. Unit tests happen. 8.
So when's the unit test going to be? If you had anything to
A gander. It'll probably be, no, it'll probably be Monday or Tuesday the following week.
Maybe Tuesday or Monday.
We have to see. Well, we'll see. Okay. So is there anything that can cancel? No. I just draw my straight line in between and I write them out. I like writing the x first. If you wrote x minus 3 first, you're still fine, right? Because these can be interchanged. Over. I ran out of room. And then you box it because you're proud of it. So is division anything more crazy than multiplication? No. If you can multiply, you can divide. You just might forget an MPV, right? It's the same steps. If you can't multiply, this is really hard. Can't simplify, both of them are really hard. So for B, the very first thing I'm going to do is flip and multiply. But remember, I have to state non-permissible values for the total right-hand side. So I'm going to go equals x minus 5. What can I take out of here?
Top and bottom,
Bottom.
3x.
You take out a 3x. So 3 and an x. And I'm left with x minus 3 times, take a 6 out because I'm flipping them, right? You can do this in one step or you can do it in two. You can flip it and then do all the simplifying. I'm just being lazy and doing it in one. Just make sure if you are being lazy and doing it in one, you actually flip them. Because some people will just put a multiplication symbol and then leave them, which is new. So then we have a negative 5 on the bottom. And on the top, we have a 6 and an x minus 3. See how I flipped them? Remembering non-permissible values of both denominators and this numerator because it was a denominator. So our MPV says 3, give me a non-permissible value? No. What about x? Just can't equal 0. This one's going to be x minus 3 can't equal 0. So x can't equal 3. Does 6 give me 1? No. I already did x minus 3. Do I have to do it twice? That's too much. I'm about negative 5. Give me an MPV? No. So that's it. X can't equal 0 and 3. We're going to draw a line. These cancel. Like I said, I just do the numbers in front and do an extra step. So I'm going to go 6, x minus 5. Can this minus 5 and the negative 5 by itself cancel? No, because x minus 5 is attached, right? So on the bottom, I'm going to have 3, and then x, and then minus 5. This x times minus 5 is actually negative 5x, not x minus 5, right? So they can't cancel. So this negative 5 should have joined the 3, shouldn't it? So we're going to get negative 15x. And then I can reduce these by taking out a 3. 6 divided by 3 is 2. Negative 15 divided by 3 is negative 5. So I'm going to get 2 x minus 5 over negative 5 x. X can't equal 0 or 3. You're going to do C and D. D is just an A plus 3. What's it over? What's in its, yeah, 1. Good job, Leslie. Okay, you're doing C and D. Try them out. So, C, oops, I got a little aggressive with that scrolling. So C, the top is a 2W. Can I take anything out of that? No, so I'm just going to write 2 and W in their own brackets because it's a monomial. There's no signs attaching it. Over 24W plus 4W squared, I can take out a 4 and a W. 24W to take out 4W is 6, plus 4W squared, take out 4W is just left a W, right? 4 divided by 4 is 1. W squared, take out W is a W. Times, I'm going to have to move these. So on the top, I'm going to have 9W cubed plus 54W squared. I can take a 9 out of both of them and a W squared. Then what's left over? So 9W cubed, take out a 9W squared, and I'm left with W plus sign. 54W squared, take out a 9W squared, and I'm left with 6. Over, now this is going to drop. So 6W squared minus 6W, I can take out a 6W. 6W squared, take out a 6W, and I'm left with W minus 6W, take out a 6W, is a really large 1. Now I have to state non-permissible values for this denominator, and this numerator, because that numerator used to be a denominator, right? So I have 4. Is that a problem? No. Then I have W can't equal 0. Then this one I have 6 plus W can't equal 0, so W can't equal -6. This one is one that confuses people. Everyone paying attention, phones down. So if I have W squared is just a W and a W, correct? So W squared gets me the same MPV as this single W. It just can't equal 0. So if you have a W or a W squared or a W cubed or a W to the 4 or W to the 5, whatever power it may be, it just can't equal 0 because it's like W times W. So don't let this one mess you up. You guys think it has to be harder. It doesn't. W plus 6 is W can't equal -6, which I already have. 6 doesn't get me an MPV. This one's going to be W can't equal 0, which I already have. And then I have W minus 1 can't equal 0. Add my 1 over. W can't equal 1. Okay? What can I do next? Yeah. First for that. Draw. Yeah. Draw the line. Because it's multiplication, I can draw a whole line. Then I can start simplifying. So I'm going to go, is 6 plus W the same as W plus 6? Yes, because it's a positive W, positive 6, positive 6, positive W. I can change the order, right? I could write this as positive W first plus 6 if it makes me feel better, right? It's just the same thing, just rearranged. So this one cancels off this one. A single W crosses off a single W. This is a single W, and this is just 2 of them. So I can take 1 off of here and then 1 off of here. So I'm left with W to the power of 1, which I don't have to write the 1. I have a W minus 1. Is there a W minus 1 in the top anywhere? No, so it's staying for life. So now I'm going to put what's just left over. If you want to reduce the 2 and the 4 and the 9 and 6, go ahead. But I'm just going to go 2 times 9 is 18. W over 4 times 6 is 24. W minus 1. And I told you we can reduce it now by taking a 6 out of both. Or you can go 18 divided by 24, math, enter, enter, and it helps you out to double check your work to make sure if you did it right. Okay? I'm going to take a 6 out of both. 18 divided by 6 is 3. 24 divided by 6 is 4. If I put these in, I get 3 over 4, so I know I'm right with what I did. My answer is going to be 3W over 4, W minus 1. Don't go distributing. Don't go foiling. This is more simple. If you put the 4 in, you're actually expanding. So the only time we put that 4 back in is like I showed you yesterday, when I said if it asks for it in this specific form and it doesn't have brackets, you'd have to put it back in, but that's it. So we stop here, and we go W can't equal -6, 0, 1. Then let's look at D. D is A minus 6 on top. Can't do anything with that. over 3a squared plus 9a. What can I take out? A 3 and a a. When I take 3a out of 3a squared, I'm just left with a plus 9a divided by 3a is 3. Then I go multiplied. When I multiply these swaps, so the a plus 3's actually don't cancel. You're going to really want to cancel them because they look like they should match and cancel. They don't cancel. So the 1 in the denominator is going to be now in my numerator. And a plus 3, I can't take anything out, so I'm going to write it as an a plus 3. The 1 in its own brackets. So I go to state non-permissible values next. Because it was a division, I state non-permissible values for these denominators and this numerator because it was a denominator. However, it's a 1. It's not going to get me any anyways. So does the 3 get me an NPV? No. A can equal 0. That's one of them. A plus 3 can equal 0. So A can't equal negative 3 because I can move it over. The 1 doesn't do anything. A plus 3 I've already stated. So I don't have to state it twice. Now, because it's multiplication, I can extend that line. Does anything cancel? No. It's trickery, because you think something should. It doesn't. So you're going to go 1 times a minus 6, which is just a minus 6, because the 1 doesn't change anything, over 3a, a plus 3. Instead of writing a plus 3 times a plus 3, I can just write a plus 3 squared. A can't equal 0 and negative 3. If the variables are a's, you can't just be like, I don't like a's. I'm making it x. They're a's. Because they're a's. So you have to put what they have. Alrighty, we're going to go through over to the next page. So you're going to do this one. You're going to do this one. You're going to do this one. The whole next page, you're going to do those 3. Then you're going to flip over and look, what were we at? Adding and subtracting. So we're not going to do those today. We're going to do these 3. And then we're going to go through them. And then I'm going to give you 2 out of your textbook. So I'll write the 2 out of the textbook at the top so that when you're done these 3, you can do those as well. So that's 5 questions. Yeah. Yeah. How'd you do on the your turn? Okay? Yeah? For example 2, we can take out a 15 and an x. $30x squared divided by 15x is a 2 and an x, plus 15x divided by 15x is a 1. X squared minus 9 is the difference of squares, so we get x plus 3, x minus 3. Multiplication, take an x out of it, we're left with x, and then x minus 3, because these swap. The top, I can take an x squared out, and I'm left with 2x plus x squared, take out an x squared is a 1. Everyone did okay to there? Yeah? They're all blank staring at me. All right. Make sure you're not on your phones. So then we can do this. We see NPVs for everything. So we get x plus 3. So we get x can't equal negative 3. X minus 3, so we get x can't equal 3. X, we just get a 0. X minus 3, we get a 3, which we've already done. X squared, when an x squared is by itself, what's the NPV? 0. And then 2x plus 1, we'll do some work, so that one's a little bit bigger. 2x plus 1 can't equal 0. Subtract 1. 2x can't equal negative 1. Divide by 2. X can't equal negative 1. So the x cancels off one of these. The other x cancels off the other one. The x minus 3's cancel. The 2x plus 1's cancel. And we're left with 15 over x plus 3. And then x can't equal plus or minus 3, 0, or negative a half. And then this one, the top left, 4x squared minus 1 is the difference of squares. So we're going to get 2x plus 1, 2x minus 1. The bottom is x plus 2. Can't do anything to it. Multiplied. Top I can take, or the bottom is now going to become the top. I can take an 8 out. And I'm left with x squared minus 4. And the top is 4x squared plus 2x. I can take a 2x out. And I'm left with 2x plus 1. In their own brackets. X squared minus 4 is the difference of squares. So I'm going to get 2x plus 1. 2x minus 1. X plus 2. Times 8. X squared minus 4 is x plus 2x minus 2 over 2 times x times 2x plus 1. And I go to state NPVs. I'm going to get x plus 2, so x can't equal negative 2. 8 doesn't get me 1. Plus 2 gets me negative 2, I already stated it. Positive 2 or negative 2 gets me positive 2. 2 doesn't do anything. X is just 0. And 2x plus 1, we did up top, I'll do it again. 2x plus 1 cannot equal 0. 2x cannot equal negative 1. X cannot equal negative a half. Then the 2x plus 1's cancel. The x plus 2's cancel. This one has an x, but there's no single x's on the top, right? So we're going to be left with an 8 on the top, 2x minus 1, x minus 2, over 2 and x. Now the 8 and the 2 I can take a 2 out of, so that's a 1. 8 divided by 2 is 4. So I'm going to get 4, 2x minus 1, x minus 2, over x. And then x can't equal plus or minus 2, 0, and negative a half. How'd you do on that one? Okay. So your homework is number 7. Those 4 questions. Remember, your homework gets handed in tomorrow. So there's the 2 homeworks that have to be handed in tomorrow. They're all from that same page. The homework from yesterday and the homework from today. They have to be handed in tomorrow when you're due a Okay? I'll show you what it is. So, let me pause this.